Good morning, students. Today we shall start the new chapter, that is numerical solution of ordinary differential equations. In last year, that means in BSc first year, we have studied some methods to solve the first order differential equation. In literature, many analytical methods are available to solve the first order linear differential equation. But in some cases or in some problems, the solution will not get, or it is difficult to solve some problems by these analytical methods. In such cases, we solve the problem by numerical methods. To describe the method, we shall consider first order differential equation dy by dx is equals to f of xy with the initial condition y of x0 is equals to y0. Now, if order of differential equation is m, then its solution contains m arbitrary constants, and therefore we require m equations or m conditions. If for first order differential equation, if we shall prescribe the condition on an initial point only, such problem is called as an initial value problem. Or for a problem second order or higher order, we prescribe the condition on two or more points. Such problem is called as a boundary value problem. In the chapter, we shall study only the initial value problem. Now, this is the first order initial value problem. dy by dx is equals to f of xy. The initial condition is given at x is equals to x0 because function is y of x, means we have taken x is equals to x0 and then y of x0 is equals to y0. This value of y of x is y0 at x is equals to x0. Now there are different methods to solve such problems. The methods are Taylor series method, Picards method, Euler's method, Runge-Kutta methods. These four methods are included in our syllabus. We shall see these methods one by one. At first, we shall see the solution by Taylor series method. To solve this, we shall consider the differential equation y dash is equals to f of xy with initial condition y of x0 is equals to y0. This is the initial value problem. At x is equals to x0, value of y is y of 0. It is denoted by y of 0. Now we have to solve this problem by Taylor series method. Now the Taylor series for the function f of x, here f of x is y of x around x is equal to x0 is given by y of x is equals to y0 plus x minus x0 into y0 dash plus x minus x0 whole square upon 2 factorial into y of y0 double dash. Means this is the first order derivative, this is the second order derivative, and next term is x minus x0 whole cube divided by 3 factorial y0 triple dash, that is third order derivative of y0 and continuing like this. Now in the equation 2, means to solve the problem in equation 1, we shall consider Taylor series for the function y of x around x is equals to x0 and which is given by equation 2. Now in equation 2, we shall put the values of y0 dash, y0 double dash, y0 triple dash and so on. Now function is y of x and given differential equation is y dash is equals to f of xy. Means first order derivative is known from this equation, means from given equation, and then you can obtain the y0 dash. Now we require second order derivative, means apply the formula of total derivative, and here which we have studied in BSc first year class in the chapter partial differentiation, and applying the formula for total derivative, we get y double dash is equals to y double dash means we shall differentiating this equation with respect to x. Derivative of f with respect to x, we shall denote it as a f of x. Okay, into derivative of x with respect to x is a 1 plus y dash into derivative of y with respect to derivative of y with respect to x, but y is f of x, means we shall consider derivative of f with respect to y. F of y means this is the y dash is equal to f of xy, differentiate with respect to x and apply the formula of total derivative. Therefore, y double dash is equal to f of x plus again here derivative of x plus with respect to that is 1 plus y dash f of y, or y double dash is equals to fx, that means derivative of f with respect to x is a partial derivative, plus what is y dash? Y dash means f, it can be written as f of y. This is the formula for y double dash, that is second order derivative. Differentiating this, again apply the formula of total derivative for this, you shall obtain the value of y of triple dash and continue like this. And then once we know the derivative y dash, y double dash, this is y dash, y double dash, y triple dash, then we can find y0 dash, y0 double dash, y0 triple dash and so on, and substitute these values in equation 2 and simplify, you will get the required solution of the initial value problem which is given by equation 1. This method is called as a Taylor series method. Now another method is Picards method, or it is also called as Picards method of successive approximations. I am writing in short. Name of other method is Picards method. Or it is also called as Picards method of successive approximation. Again, we shall consider the differential equation, no doubt it is the first order differential equation. Y dash is equal to f of xy with initial condition y of x0 is equals to y0. Okay. Now y dash is equal to f of xy. That means it is a dy by dx, because we know that dy by dx is denoted by y dash. Means this differential equation is dy by dx is equals to f of xy. Okay. Now this equation can be written as dy is equals to f of xy dx. That means we have separated the variables and then integrating on both sides from x0 to x. Integrating both sides from x0 to x, we get this is the integration from x0 to x. Integration from x0 to x. Okay. Only we have considered the differential equation y dash is equal to f of xy, and left hand side y dash can be written as dy by dx, and then we shall write dy is equals to f of xy dx and integrate both sides from x0 to x. Then integration of dy is y limits x0 to x is equals to the function f of xy is unknown, and that's why we cannot find the integration without knowing the function. For that purpose, we shall put the right hand side as it is x0 to x f of xy dx. Now upper limit is y, x, actually it is y means y of x, means x as it is, therefore upper limit y, this is a y, minus lower limit x0, it means it will become y of x0. Okay, function is y of x, upper limit is x, therefore it remains y of x as it is, but y of x is denoted by y. Lower limit is x0, therefore y of x become y of x0. But it is given that y of x0 is a y0, this is the initial condition, and therefore we shall write this as a y minus y0 is equals to integration x0 to x f of xy dx. Okay. Now this equation is written as, transfer this y0 on right side, it will become positive. We get y is equals to y0 plus integral x0 to x f of xy dx. Result is our first equation. Now to find out first approximation, on right hand side we replace this y, replacing y by y0 in RHS of equation 1, and therefore the first approximation is y1, means first approximation is denoted by y1, that is first approximate value of the y. It is denoted by y1, and it is obtained by replacing y by y0 on right hand side of equation 1, and therefore y1 is equals to y0 plus integral x0 to x f of x y0 dx. Using this equation, we can find first approximation, that means first approximate value of y. Similarly, we can obtain second approximation, as we can put the value of f of xy0, because we know the f of xy. In f of value of f of xy, replace y by y0 and simplify, you will get the value of f of xy0, and you can integrate d. This means right hand side can be integrable. We can find the value of this. That means we get the first approximation y1. Once we know the first approximation y1, in equation 1, we replace y by y1. We replace y by y1 in equation 1. Once we know the value of y1, and then equation 1 becomes y is equals to y0 plus integral from x0 to x f of x y1. That means first approximate value y1 dx. Okay, and this is the second approximation. The second approximate value is given by y2 is equal to y0 plus integral x0 to x f of x y1 dx. Okay, by the similar manner we can obtain third approximation denoted by y3 is equals to y0 plus integral x0 to x f of x. We have to replace now y by y2. That means second approximate value dx. And continuing in this manner, we can find or we can write general formula which is yn is nth approximation, nth approximate value is equals to y0 plus integral from x0 to x f of x y n minus 1th approximation 1 dx. Now this is the formula for corresponding approximate value of function. We may call this as a Picards formula also for successive approximation. It is called as the Picards method of successive approximation because we cannot find directly nth approximation or for example third approximation. We have to find first approximation first, then second, then third successively. And so this method is called as the Picards method of successive approximation. Now in next lecture we shall solve one problem on the Picards method. Thank you.